Okay, so this is the very famous Whoosh bottle demonstration. What I'm taking is a 5-liter empty container. And what I'm going to do is I'm going to put some methanol. Now, methanol is nothing more than wood alcohol. Believe it or not, as we've talked about, wood has different types of volatile chemicals that include wood alcohol, famously called methanol. So what I'm going to do is I'm going to add some methanol in this container. So let me do that now. So I'm going to take some methanol, okay, and I'm going to empty it in my container. Certainly just put enough, I didn't measure. And what I'm going to do is I'm going to evaporate it. So I'm going to turn, and I like to talk about evaporation as a cooling process at this point. And I have students feel the end of this, and it feels cold. And if you can see, all the alcohol that I've added, okay, is now a vapor. Okay, I've increased the surface area. As you can see, I shouldn't have much emptying out. More is not better in this case. So I've got alcohol vapor in here. Now what I'm going to do is I'm going to take, okay, this striker that is sending over nothing more than a spark, okay, across this speaker wire. You hopefully can pick that up. If not, you can just trust me that there's a little spark here. And that's going to be the activation energy that's going to react oxygen that's in this container, as well as nitrogen, but it's going to be oxygen that reacts with the alcohol vapors, the wood alcohol. Okay, and I've talked about this. Fire that burns, you see, burns differently initially than after a few minutes. You see a fresh log put on the fire, you see it glow brightly, the flames exude out from the fire, but over time you just see that piece of wood become glowing embers. What's the difference? Well, initially the wood has its volatiles, it has its alcohol that burns, it gives it its flame that comes off the wood, and then eventually you're left with just the carbon interacting, okay, in the cellulose to the oxygen, and you don't have the liquids evaporating. Okay, so in any case, I'm going to put this sparker in here and try not to get the end wet. And my hope is to react the oxygen with the alcohol. Now I've taped this with clear tape because sometimes 1 out of 100, sometimes these actually will explode. So this could be a dangerous result. So I've definitely taped it to make things safer. So here we go. I'm going to step off to the side. I'm going to light this, and I have an extra part to this. So here we go. 1, 2, 3. And I'm going to quickly cover it. What's nice about this reaction is you got a partial vacuum that's been created from this in this demonstration. You can hear the hissing, okay? And clearly what happened here is we created CO2 and gas, and we've heated the gas particles that were left. Now some students say that you ate up a lot of the oxygen that was in here, therefore there was less molecules, therefore the pressure dropped. Now pressure is due to molecules colliding, okay? And we know there's pressure on the inside and pressure on the outside. That was initially the same. That's why the container didn't implode initially. But what happened was, by me creating this exothermic reaction that gave off heat, I created gases that expanded out, and the heat, okay, that was left in the container with fewer particles, because again, when you heat a gas, gases expand. And when they expanded out the opening, I was left with gases initially, because it didn't happen right away. It only happened when I covered it. So the gases initially, okay, expanded out, but it didn't collapse until I covered it. When I covered it, what I did is I stopped the fire. I stopped the oxygen being added to the burning alcohol, and the fire stopped, and the remaining particles inside cooled. So the reason why it didn't implode immediately was because the gas inside was really warm, and what it did is it moved faster to overcome the lack of particles left